Hello friends, welcome back to my channel Techno Education Academy. In this video lecture we will discuss the working principle of Loeffler boiler. Loeffler boiler it is a high pressure forced circulation water tube boiler. There are two important features of this boiler. The first feature, the use of two turbines. In this boiler here we are using high pressure turbine and low pressure turbine, and between these two turbines we are using reheater. The second important feature, the use of superheated steam to generate the steam. The principle behind the working of Loeffler boiler is evaporation of feed water by means of superheated steam from superheater. This prevents any soot deposition since Loeffler boiler are used for marine application. In this boiler we can also use saline water for its operation. Now we will discuss the basic component of Loeffler boiler. The major difficulty experienced in the La-mount boiler is the deposition of salt and sediment on the inner surface of the water tubes. The deposition reduces the heat transfer and ultimately the generating capacity of the boiler. This further increases the danger of overheating the tubes due to salt deposition, as it has a high thermal resistance. The difficulty was solved by Loeffler boiler by preventing the flow of water into the boiler tubes. Most of the steam generated outside the feed water using part of the superheated steam coming out from the superheater. The arrangement of different components and water and steam circulation as shown in diagram. So first of all we will discuss the different components of the Loeffler boiler, then after we will discuss its working principle, advantages and disadvantages. The first component is feed pump. The feed pump is made of high strength, corrosion resistance and erosion resistance Martensity chrome steels, and it serves to feed the boiler with a quantity of feed water corresponding to the quantity of steam required in the boiler. The second component is economizer. As we know that what is the function of economizer? Economizer, it is a heat exchanger. Here we are using waste heat from the flue gases, and these flue gases will pass the heat to the coil of tubes of heat exchanger, and it will increase the temperature of water. So an economizer is a device that facilitates the exchange of heat energy between the flue gases and feed water before the flue gases leave the boiler through the chimney. So it will increase the temperature of water, and it will reduce the fuel supply in the combustion chamber. So finally the thermal efficiency of the boiler is increases. The third component is air preheater. Air preheater is a device designed to heat the air. It increases the efficiency of the boiler by heating the air through the exchange of energy between the flue gases and air before sending the air to the grate of combustion purposes. So air preheater are installed between the economizer and chimney. It is also one type of heat exchanger, and it will increase the temperature of air, and finally the combustion efficiency will be increases. The next component is the evaporator drum. It is a reservoir of water and steam. Next one is mixing nozzle. Mixing nozzle facilitates mixing of feed water and superheated steam by evaporation in the evaporator drum. Next one is steam circulating pump. A steam circulating pump is a centrifugal type pump designed to generate forced circulation in the Loeffler boiler to transmit the steam into the radiant and convective superheater. Here we are using two types of superheater, radiant superheater as well as convective superheater. So superheaters are coil type heat exchanger to convert the low quality steam into high quality steam. It will remove the moisture content from the steam. As we know that superheated steam, it will behaves like a gas, and it will follow all thermodynamic laws, and there is no any moisture content will be there in the superheated steam. Here we are using two types of superheater, radiant superheater and convective superheater. Radiant superheater, it is placed in the radiant zone of the combustion chamber thus heated by direct flame of radiation, and convective superheater, it is placed in the convective zone of the furnace in the path of hot flue gases, and it will increase the temperature of the steam to the desired temperature of 500 degrees Celsius in the Loeffler boiler. Superheating the working fluid increases the average temperature of heat addition, thus efficiency of the plant it will be increases. The next component is reheater. As we know that the reheater, it will be installed between two turbine, high pressure turbine and low pressure turbine. So whenever the steam will be expanded from high pressure turbine, so at that time some moisture content will be there due to expansion of steam. At that time some pressure and temperature drop will be there. Okay, so it is heated in the reheater, and then after it will be expanded in the low pressure turbine. So the quality of steam at high pressure exit is achieved by reheating the cycle, which increases the efficiency of the cycle. The next component is turbine. So turbine transform the energy of steam into work. Okay, it is an output device. Okay, in this turbine the steam will expand, it will produce the electricity, and it will connect it with the generator. Okay, and through the generator we can transmit the electricity for domestic as well as industrial purposes. The next component is chimney. So chimney provides for the exhaust gases to be released into the atmosphere. Now we will discuss the working principle of Loeffler boiler. The pressure feed pump draws the water through the economizer, and it is delivered it into the evaporator drum as shown in figure. About 65% of the steam coming out from the superheater is passed through the evaporator drum in order to evaporate the feed water coming out from economizer. As we know that, okay, here the evaporation of feed water by means of superheated steam from the superheater. Okay, so the steam circulating pump draws the saturated steam from the evaporator drum and is passed through the radiant superheater and then convective superheater. About 35% of the steam coming out from the superheater is supplied to the high pressure steam turbine. The steam coming out from the high pressure steam turbine is passed through the reheater before supplying to the low pressure turbine. Okay, as we have already discussed. Okay, in between two turbine there is a reheater. So whenever the steam will be expanded from the HP turbine, so at that time some moisture content will be there. Okay, so this moisture content it will be removed by reheating process in the reheater, and then after it will be expanded in the low pressure turbine. The amount of steam generated in the evaporator drum is equal to the steam tapped at 65% from the superheater. The nozzles which distribute the superheated steam throughout the water into the evaporator drum are of special design and avoid priming and noise. This boiler can carry higher salt concentration than any other type and is more compact than indirectly heated boilers having natural circulation. These qualities fit it for the land or sea transport power generation. Now we will discuss the advantages and disadvantages of the Loeffler boiler. The following are the advantages of the Loeffler boiler. The first advantage, Loeffler boiler can use salt water, or we can say saline water, for steam generation. This boiler can carry a higher concentration of salt than any other type. The deposition of the salt and sediment on the inner surface of the water tube is eliminated, which was the major difficulty experienced in the Lamount boiler. It is capable to react rapidly to sudden variation in the load. And the last advantage, it is more compact than indirectly heated boilers having a natural convection. Now what are the disadvantages of the Loeffler boiler? The first disadvantage, tightness of high pressure gas passage is essential. The second one, using evaporating drum makes the system or a wool setup bulky and costly. And the heat transfer rate decreases due to bubble formation. These are the application of the Loeffler boiler. Loeffler boiler with a generating capacity of 100 tons per hour of steam and operating at 140 bar and 500 degrees Celsius have already been commissioned. This boiler can carry higher salt concentration than any other type, and for its compact size it is suitable for land or sea transport power generation. And these boilers have marine application, and are used in the textile and medical industries. So thank you friends for watching this video. I hope this content it will be helpful to you. If you would like to watch this type of more technical videos, then please subscribe our channel and also share with your friends. Thank you friends.